Hey, hi, my name is Hank Ayers, and I'm with a company called GPM Hydraulic Consulting. I want to talk just a little bit about position transducers. Now, in the old days, there were transducers that were used that were what you call a linear potentiometer. Problem with a linear potentiometer, it was contacting, which means that the wiper would be sliding against a resistive strip, and this will cause them to wear out relatively fast. And of course, there are linear transducers that are what we call an LVDT, a linear variable differential transformer. Problem with those are somewhat limited in the length and they're somewhat affected by magnetic fields. More commonly, what we see in industrial applications is what we call a magneto-stricted position transducer. Now, commonly these are referred to as a temposonic. They're referred to as wands, possibly referred to as probes. But essentially, this transducer works on a principle called magnetostriction. And magnetostriction's been around, was discovered several hundred years ago, but it was adapted to this particular application sometime around 1975. Now, a magnetostricted material is basically a material that typically is iron, nickel, or cobalt, that when it's affected by a magnetic field, you get a small molecular distortion. And what we have inside this transducer, this is indeed, by the way, a temposonic transducer. What we have inside of here is what we call a waveguide. And that's made out of that magnetostricted material. Now, this particular sensor works because of the interaction between two magnetic fields. There's a magnet. A magnet will be attached to the hydraulic cylinder's piston or any other thing that you're measuring a linear motion on. And as the magnet moves up and down, you have a magnetic field that moves up and down the position sensor. The second magnetic field comes from a pulse. It's what we call an interrogation pulse, and as that interrogation pulse goes down the waveguide, and it travels somewhere around 3,000 meters per second, it also creates a magnetic field. Now, these two magnetic fields will interact, and this pulse magnetic field will collapse once it hits this magnet. Now, once that occurs, then you have a return pulse, or what is known as a strain pulse, that propagates from the distortion in the waveguide in both directions. It'll propagate out towards this end and dissipate out on the end. It'll also come back, and it's sensed in the head of the transducer and these electronics here. Now, the way this all works, it's basically time-based. Inside of your electronics housing here is a counter. Basically what we do is we measure the time from when we fire the interrogation pulse until the time it's received back, and at that point we determine very precisely what the position of the cylinder is. And typically these things have an accuracy of somewhere around 1/1000th of an inch. Now, coming out of the connector here, this goes back to a control system that will very accurately tell the control system where exactly that cylinder is. Now, how do we troubleshoot these? Well, there's several ways. This, like I said, this is an actual temposonics, and this one has some LVDTs on it. Right here on the end of the housing, there's a red one and a green one. As long as you have a green LVDT, everything's good. A red one typically means you have a fault. Now, that fault could be an issue with the power supply of the transducer, because they do run on a 24-volt power supply. Or you can use some type of test box. All of these manufacturers make a test box. There's several third-party companies that make test boxes for these. Those test boxes are very useful. One thing I like about this particular transducer is it is separate. It does have a separate sensing element that comes out of the pressure tube. Now, that is very handy, because whenever we want to change out this transducer, we don't have to break a hydraulic seal. Your pressure tube will stay inside the cylinder. So all we have to do is take out 2 screws here, and everything slides out. We can slide the new one back in, and then we're ready to go. If you found this tip helpful, please visit gpmhydraulic.com and look at see some of our other videos we have available, and also learn about our two-step training process.